All right, thank you all so much. So this is going to be our technical panel. I'm joined by Eli Riggs from Polygon Zero, Michal Klein from Aztec, and David Wong of zkSecurity. So first, it would be great if everyone could just kind of introduce yourself and talk a little bit about what you're working on at the moment.
I'm Eli Riggs. I work at Polygon on Plunky 3, which is a proving backend, mostly focused on Starks. And recently I've been working on low-level optimization and making it faster.
Yeah. Hello, I'm Michal Klein. I work on the Noir compiler. I focus on the type system and making sure everything is correct. So I've been working on a lot of different tests for that, as well as trying to make the type system more usable and add more different types of checks. Of course, there's many ways we can make things more usable, so it's very ongoing.
Oh, and I'm David Wong. I have a startup called zkSecurity, and we do audits of zk proof system and stuff like that. We also do dev and research stuff, but yeah, that's about it.
So excited to be here with you. David, I guess this first question at least somewhat starts with you. So a year ago on the podcast, you mentioned that a lot of your audits were for low-level infrastructure in ZK, and there was less sort of app development at that time. Do you feel like that's changed since then?
I guess since then we sort of looked more at like circum circuits, but at the time I was talking about frameworks like Noir, other maybe ZK VMs or Leo of Leo, O1JS of Mina, the different frameworks that were for the most part not launched yet. Since then, I guess Leo is the only one that launched, I believe. So we have started looking at some Leo stuff, but we're still in the phase where a lot of these frameworks haven't. Oh, Mina launched also, sorry. So we're doing more like dev stuff on Mina, but we haven't really seen too much I guess Noir so far, or O1JS for Mina, and some Leo. So we spend maybe now 50% of our time on proof systems. So, and if its application is sort of still in Circum, which is still not the most modern framework, or yeah. And I guess we've done some Noir, L2, and this kind of thing.
I was struck that I think like more than half of the companies in A16Z cohort are using Noir, even though this hasn't like officially launched. And you see some trends of like people picking up things that aren't like kind of 1.0 yet. How do you all like feel about that approach? Working with something before it's officially sanctioned.
Well, definitely we don't recommend Noir for production use at the moment. But since Noir is very Rust-like, we find that there's a lot of developers who are comfortable in a Rust-like environment and develop in it for those reasons. We're also fairly performant, which I think helps when you're prototyping things. And we have normal control flow, normal functions, impulse traits, things that you would expect in a high-level modern programming language. And I think that's part of the reason why so many people have been picking it up.
I think it's interesting because traditionally cryptography is a very conservative industry, very reticent to don't really go in crypto, it's just use the NIST standards, or maybe this one other thing that isn't a NIST standard, but everyone likes it. But usually it doesn't really matter for end users because I have a secret box, or I'm encrypting this thing, and maybe if I use the 1999 NIST standard, it'll take a few more CPU cycles or something, or it might be breakable. But you have these primitives, and it doesn't really matter what standard you use. And so it's okay for them to be super conservative. Whereas now we have new systems coming out every week, and they're really useful, and they impact the way that developers build products and the way that users can use it. And so it's really strange to we can't be super conservative and say oh no, we need to wait 10 years for this to be standardized. Right?
Yeah. At the same time, when Solidity came out and Ethereum came out, we saw like so many bugs that were exploited for like millions of dollars. So it is also exciting to see what zk bugs will be exploited for millions of dollars also. I mean, I say that, but parts of me is also scared, but the security person that has lived through a lot of these hacks is also interested in seeing actual stuff getting exploited. I don't wish it, but it's, yeah, it's, like you're saying, it's all pretty experimental, like not really ready for prod, so things are gonna break at some point or another. But yeah, let's see how it goes.
I'm not saying like that we don't need to worry about it. I'm just saying that you actually, okay, if something is broken, you can just swap it out. You actually need to like invest all of your developer time into building an ecosystem and like hope that it's a good solution. It doesn't get broken. We've been talking about something else. Never mind.
Do you feel like it's that modular that you can just swap it out at this point? I guess I'm also curious, like you mentioned it not being recommended for production use, and this has more to do with like, you're not quite sure that it's secure or like finished in some ways versus like performance issues.
Yeah, so that's mostly just that we're not at 1.0, and until we reach 1.0, we haven't actually gone through and been as sure as we can that everything is ready. But I think part of what y'all have been referencing is that Noir is one of the few ZK languages that supports multiple backends. We support something like 5 to 7 different backends at the moment, and because as Eli was mentioning, the crypto changes so rapidly, many of these other languages are really tied to a specific type of crypto. And if you use them and that crypto changes because it hasn't been proven out, you might have to rewrite much of your product. You might need to re-architecture your product.
Mm-hmm.
So the premise of Noir is that you can be a little bit more isolated from that rapidly changing part of the ecosystem.
You're protecting them for something that you know is going to happen, which is somewhat easier for
planning ahead, yeah, exactly.
Excellent.
What are the backends? Can you?
Off the top of my head, I think that there's a Plonky 2. We have Brettenberg itself, which is our core Aztec one. There is a Nova Hypernova backend, Groth 16. Yeah.
Oh no.
Other than that, off the top of my head, I'm not sure of the full list. We have Awesome Noir on the Noir repo, and you can look at the current list of well-known backends.
Cool. Pretty interesting. Yeah.
I had one more question for you, I guess, just because we're on it. So you focus on the Noir type system, and like I love nerding out about language theory. Is there a way that you approach a language differently, knowing that it's like privacy and security focused, as opposed to like just general kind of language theory?
Yeah, I would say that there's a lot of ad hoc types in something like TypeScript or a dynamic language or like a class-based language. A lot of things are more ad hoc. You can kind of mix in things at arbitrary points, and it can be much harder to actually trace what is the full spec of this code. So we look for more static typing, more clear type system facts.
Mm-hmm.
Like we have both types, and then we have the types of types to try to make sure that there's even a higher level of consistency. And that would be the general approach, I would say, that's more specific. We want the code to be more easily auditable than something with a lot of mix-ins.
For sure. And I guess for all of us, at least my feeling was that zkVMs were like this major unlock in terms of like usability of this new technology. So that's one kind of developer tooling thing. Do you feel like there are other developer tooling things that we should start investigating in ZK? Just like quality of life for someone writing some ZK app as opposed to something else.
I would say that most of the developer tooling is just standard developer tooling for any language. You want a language server protocol so you can easily use it in an editor. You want things to be able to pretty print and format your code, right? So like most of it's fairly standard. Things that are a little bit more specific to zero knowledge might be like data flow analysis to actually try to trace, okay, I have this secret information, how does it get traced through the code? Or I have unconstrained variables. How can I try to make sure that those are constrained and that I've actually pinned them down to exactly what they need to be? These are a little bit more unique to ZK, but I would say the vast majority is just simple usability tools that you'd see in any modern language.
Can I ask you a question actually?
Yeah.
So like we've seen a lot of different languages for zk, and like some of them are. Can I actually ask that?
Yeah, go for it.
And like some people are introducing hints, some people are removing hints. I've seen that Noir has like these unconstrained functions. Like I was wondering how you guys thought about that, and also the risk of having these in the language. Since like maybe most bugs come from having developers access this kind of, having this kind of leaky abstraction. I don't know if it's a leaky abstraction, but maybe you can.
Sure, I can comment generally on it. So for the audience, the unconstrained function means that it doesn't actually get run inside of your circuit. So for example, if you have a sorting algorithm, much of the sorting can actually happen outside of the circuit, and then inside of the circuit you just verify that the results are correct. Similarly, if you're doing crypto, you might just be able to check that the signature is correct at the end, where the unconstrained function was actually creating the signature. So these definitely can be a foot gun. We require any unconstrained calls within your circuit to be in what we call an unsafe block, kind of like unsafe code in Rust. And while it's impossible in general to tell if you fully constrained your code, the performance benefit from being able to do this when somebody knows what they're doing, I think is too great to leave it out of the language.
Yeah. So I guess we have just for context, we have not a competing language, but a very similar language called NonM, also Rust inspired, but also Golang inspired. And some of the design decisions are very close to what we did. I think we sort of did that in parallel. But some of the design decisions were also very different. Like we didn't want to introduce hints in the language because we saw so many bugs because of hints. But now we realized that by not having hints, like we're basically constraining developers too much, and it's very hard to make any progress. So we're sort of in this kind of at least for like circuit frameworks, not zkVMs, we're sort of in between this kind of. Yeah, do we create a leaky abstraction that's very powerful, or do we constrain developers but prevent bugs from being created? And yeah, it's a tough choice.
Yeah, so I would say that the default should always be as safe as possible, and you should allow as well documented as possible and as clear as possible exceptions when that's what's needed. We also have things like compile time code, so you can try to like generate as much as possible at compile time. And a couple other things in our API and our standard library that would allow you to get a little bit closer to the base circuit level.
I guess, all of you probably know better than almost anyone that some of these core systems are not bug-free. We talked about this a little bit, but how do you feel about like starting to test those out, developers starting to build on them before you've reached 1.0, et cetera?
As long as they know that we know that we have bugs and we have a lot of open issues for closing bugs, then I look at it as free testing. Please open an issue if you run into any errors.
Yeah.
Please help us test the compiler. We have roughly 700 tests just on the Noir front end, and I think we could easily use 7,000 tests.
Yeah, it's like when developers are fuzzers,
Exactly, developers can be fuzzers
The
too.
monkeys on the keyboards.
Yeah, I've written a couple fuzzers. We had an external partner write a couple fuzzers as well. I imagine by the time we hit 1.0, we'll probably have a couple more fuzzers. It's very hard to test a compiler and often takes quite a long time. So yes, I really appreciate everybody that's been working on it before all of these bugs are fixed.
This was a topic we talked about at the last CK Dive a little bit. There tends to be like sort of redundant work or people on different teams working on things in parallel in this space. You do also see people like co-authoring papers or contributing to open source in good ways, but there's a lot of like performance race, or I'm not sure if this counts, but like building two very similar languages sort of in parallel. And I wonder how you think about collaboration versus like each team figuring out what's good and sort of doing it, because some of this feels pretty homogenous, I guess.
Yeah, we just met, but I was talking a lot to the previous developer, Geffen, and we actually inspired each other a lot in different design decisions. So sometimes it can be very collaborative, depending on the teams, I guess. But yeah, Aztec, we've had good relationships so far. We also edited some of the code that they created. But you know, people want to have fun and people want to create, like, they want to rewrite the stack from scratch. And since things are so early, I think it's very doable and people actually innovate by doing this. And so we're definitely pretty far away from, I know a lot of people are always asking about standards also and these kind of things. We're pretty far away from real, like, big, you know, government or banks, institution adopting these kind of things. And so we're also pretty far from standards and these kind of things. So for now, I think it's good to, like, that everybody's sort of replicating the same work and trying different things and collaborating. And I think that's the good thing about the zk field right now.
I would say that it's definitely mixed. There's a lot of different companies that are doing fairly similar things, but as Eli pointed out recently, like, a lot of that is due to the crypto being different. So if your underlying crypto that you're then proving in your zero knowledge circuit, it has very different features. Some proof systems are highly specialized to very specific types of operations, perhaps more database or more GPU friendly type operations, then that can radically change what the rest of your stack ends up looking like, even if the front end for your language is Rust-like. So I would say that divergence is, there's some, like, people wanting to roll everything from scratch, and so they just make it all from scratch. And there's some that is just using different crypto and that just being somewhat incompatible. But I would say that any company that's open source and going to events and talking to people is slowly sharing all that they have, right?
Yeah.
I feel like we're in a pretty good place actually right now. We're like, yeah, we have a lot of different pieces of software doing the same thing generally, but like they are filling their own niche, and I feel like we don't have more than maybe 2 overlapping implementations for any given niche. Like right now, Plunky 3, we're kind of racing Stu, the other zkSecurity implementation, but like it's good to have a little bit of competition. I don't feel like we have too much overlap in the software space right now. It feels like, it feels good.
So we can have one more Wong implementation.
I think 2 is good. But like, if you're like slightly in a different niche, then that's great.
Yeah.
Yeah, but we don't have too many things like directly overlapping the same niches.
Do you think of that as the main distinguishing thing of Plunky 3 is that it's zkSecurity? Or like it attempts to do other things and be ambitious in other ways too?
It is ambitious. Right now we're focused mainly on zkSecurity. It does claim to be a general purpose. Like we will eventually have different actual polynomial commitment scheme backends. Right now we're very focused on Starks, and I feel like trying to get good at the other PCSs is like not worth it at the moment until someone needs it. But we are claiming to be a fully general toolkit, and it's structured in such a way that we can't add more PCS backends. We just don't really have a reason to at the moment because zkSecurity are the best that we found.
It's starting to veer into product, but on-chain identity feels like huge product unlock. You could talk about like what that gives us if you want to go in the product direction, but could you also speak to like how zk uniquely does that quite well, does identity quite well?
I mean, I can start, but I don't have much to say. I've actually not seen that many zk ID protocol. So I guess people are still trying to find product market fit there. Actually, I'm seeing mostly proof systems or very low level things. But yeah, I'm interested to know if you guys have seen a bit more interesting things. Do you want to share what I mean?
The main application that I've seen is that usually when you try to prove that you have an identity, let's say you have a government issued identity like a passport or a driver's license. If you want to use that for a specific business, you have to give them like a whole copy of your driver's license, a whole scan of your passport. You might have to hand it to them so they can use some sort of physical device or hardware to actually pull data off of it, and that's a very high level of trust. But in a decentralized system, we have more incremental levels of trust. And so what you can do in a zero knowledge system is validate that your identity is signed by the issuer, and then pull out a single proof, like your age is within a range check or you live within a certain domain, and prove just that externally, publicly, and have the rest stay within the private circuit. So this is where I see zero knowledge being, specifically private zero knowledge, being more generally applicable to identity, is that you can have incremental proofs of identity. Not just having the entire identity at once, but little tiny pieces when you need them.
Yeah.
You made me feel like, yeah, zk credits or zk passport or all these things, but yeah, I haven't seen really these being like deployed and actually being used to do interesting things like maybe KYC, like have a centralized place for KYC. I don't know what sort of applications we could have.
It's like that's been like the compelling story for a while. It's like zk gives you this, like you can vote with it, or like you can move around, personal information doesn't get shared through it. I think it was Nico that mentioned maybe like a French election, that the online portion of it that you could opt into use zero knowledge in some way. Microsoft does it with supply chain at this point. These things feel interesting because for a while it was just talked about, and then someone would be like, it happened, and you'd go and look and like it didn't actually happen. But I don't know, like WorldCoin, etc., for biometrics, and biometrics being more adopted in general technology, it feels like there's some opportunity there as well.
That was my belief for a long time, was that people don't actually care that much about privacy, and that like, because zk, they do?
I said amen.
Amen. Like zk is not, most people are not doing zk. Like, we don't really, and then we'll like write a whole paper and at the very end, like in the appendix, like, and if you actually want zk, like you can do this and blind it, but we didn't really try it, but we're pretty sure it works.
Right. We understand you don't actually want zk.
Yeah.
You just want compression.
Yeah.
You want your gas. Yeah.
So it was my belief that no one cared about privacy, they cared about compression. It seems like that might not be the case. People might actually care about privacy.
Well, I would argue that if we want to get the best compression, where are you putting your data when you're compressing that computation? And if you're not posting the majority of the data on-chain, and you're not making it available to the people who have the on-chain hash of your large amount of data, you're probably going to want to use privacy just to distance the data in the computation from the computation itself.
Okay.
And what you said made me think of, like I like what Henry said, like from Penumbra, like most users don't care about privacy, so you have to build something that's better for them and faster for them, and if there's privacy added to it, then they will benefit from it, like for free. But that shouldn't be that shouldn't be how you attract users, because most users don't understand it, don't care about it. Privacy comes from developers or designers caring about it and adding it to their products.
Can I add something here maybe?
Yeah, totally.
Because I think users care about privacy. We have two users care about privacy, but it's different privacy that we're talking maybe. So nobody would be okay to have a salary on chain. At least the vast majority, if you ask, they don't want that the neighbors knows what they are earning. And we can't guarantee this to this day on chain.
So I would argue against. So maybe we should repeat the question, or since you're not on mic,
Sorry.
were you saying that users do care about privacy to get a salary? Nobody wants their neighbors to see how much they're getting paid or these kind of things. So I've heard that argument a lot actually, and I've always felt like there's another way to think about it. Is that most people actually don't care about being the custodians of their own funds. And so if most people use a custodian, and company also use a custodian, like Coinbase or something like that, then you wouldn't see anything anyway. And so if we think about the real world with real users, not just niche users and like power users and these kind of things, most people are going to use custodians, and so to me, it's not really that much of an issue if you think about it this way. But I'm not the most pro privacy person you can talk to, and maybe people have stronger opinions there.
Well, I would give the example of types of businesses that won't even touch on chain currently because it doesn't offer as enough privacy. And that would be the legal field, where if some of your legal documents are leaked before the trial, that can end up very, very poorly for the lawyers. Or HIPAA, where there are very strict legal requirements on not sharing medical data. And nobody who has to deal with HIPAA really will ever put anything on a public chain. They might try to use something like Hyperledger, which is like a fully private blockchain where only they can access it. And maybe you have a Hyperledger network that is shared between a couple HIPAA compliant places, but they would never pin that HIPAA data to anywhere. They have no way of guaranteeing that the hash functions won't be cracked and you won't leak the most essential bit of the user's information. So they'll just never pin their data to a public chain. I think we open up very commonly used businesses. I mean, like, we all interact with the legal system in some way or another. We all interact with the health system in some way or another. It'd be great if they were able to benefit from the scaling.
Maybe just a rebuttal on that, but I guess when we're talking about users, I would say most users don't even care about HIPAA also. Like, people care about HIPAA because like there's a regulation, and if you're like a hospital or something like that, then you have to care about it because you don't want to get fined. But so when we're talking about like these kind of things, we're talking about different protocols with different types of users, like not like human users, but more like institutions or like I don't know. I think it's a different type of concept, and so there it's interesting to think about privacy, to allow different organizations to collaborate and share data. But it's a different problem for like users need the privacy, and yeah, I guess that's what I would say.
Well, I think we could keep going on this topic, but just as a very, very small rebuttal to rebuttal. I have talked to several of my doctors and asked for my HIPAA data. And they have told me, since I don't have a HIPAA compliant system to receive that data, since I am not a doctor with a HIPAA software system set up, they won't even give me my own data necessarily. That I would need to prove that I was able to receive that data. Now, some of the data, of course, you can easily get in paper format, and that's not this, but let's say you have a medical scan, it might actually be very difficult for you to get your own data.
Yeah, I just went to the doctor last week. Let me tell you all about that. And they made me sign these papers, and I looked at the back of the papers, and it was like other patients' data. I didn't use other patients' data to like print on it to make me sign them. So I don't know. It's it's the wild, wild west out there.
It does seem like a lot of the privacy stuff is top down, or like paternal, rather than like Apple will put the like privacy. This app will like read your email. Google, like when you sign in with Google, it'll be like this app can see your email. It's like all top down. Like the designer cared about your privacy.
Or WhatsApp enabling end-to-end encryption for everyone, when I don't think anybody really asked for it, but we're all benefiting from it now. Yeah.
But it is a great point though. Like, it's because people usually just trust Google, but like, if it's all going on chain, then that actually does matter. There are a few things that people do care about, and it's like not being sandwiched, like order flow. People want it to be private, and yeah, probably their salary and like their social security number. There are a few things that users do care about privacy, but yeah, it's about custodianship and where it is, and whether they just like vaguely trust the person being the custodian.
And even being sandwiched, I mean like envy or arbitrage issues.
Yeah.
Like, you don't necessarily need privacy to solve these issues, right? Like you could have like commit and reveal schemes, right? Like, you don't.
It's a form of
It's-
privacy.
Yeah, but it's.
Yeah.
We can argue, I guess.
Yeah. And commit and reveal doesn't solve it fully. But yeah.
I mean, yeah, we can argue on, like, there's all these schemes, right, where you like encrypt all these things, you order them, then you threshold decrypt. I wouldn't call that privacy when you like end up decrypting things and it's in plain text. And I think there's a lot of different ways to solve these issues, and yeah, users care about not losing their money, I guess, but not necessarily about how you implement that. And, yeah.
Yeah, well, commit reveal is very slow, so if we can scale faster than it.
Is there any area in zk that you wish got more focus at the moment, or that you think is especially important to handle?
Yeah, I would say to me like applications. Like I want to see more applications. Like we talk so much about proof systems and frameworks and these kind of things, but at some point, what's really interesting is to see what people can do with it in blockchain or outside of blockchain. And the other thing I'll say is like client-side proving also. Like I feel like it's sometimes kind of forgotten, but I think it's actually super interesting and super impactful. And so that's the other one.
You mean like seeing if it's possible, enabling it?
Yeah, client-side proving is like, can I prove that in my browser? Can I prove it on my mobile phone? Or do I need to like delegate the proof to like some service or a T or whatever? But can I just do it myself? Or do I need to delegate?
Yeah, I'm also very, very interested in client-side proving. I feel that the mobile device, the browser, and then the power user's computer are all three different client-side proving environments with very different constraints, and I think that there's a lot of limits to be pushed. We've talked about using zk for gaming. Well, of course, a lot of gaming happens on a mobile device or is browser-friendly, but a lot of gamers have very powerful computers in comparison to a mobile device. So what's the most client-side proving that's interesting we can do on a gaming PC?
Another question?
Yes, a question for you.
Yeah, but they want to use it for ray tracing. They want the nice reflections. They don't want like zk.
Yeah, but that's all on the GPU. Do you necessarily use all your CPU and RAM, like while you're loading into the next thing? No, that you're probably just copying things from an SSD while you're loading. You could be doing a proof that the game was successful and nobody cheated in the middle of that.
But that's not like, what do you, okay, I don't know how relevant this is. Like, what are you proving? Like, you have this like client server architecture. You can't prove that you didn't have wall hacks.
Well, it really depends on the game, right? I'm not a game designer, so it's hard to say, but let's say you have economics in the game. Proving that there's not double spend is something we could do in the 60 seconds that you're loading into the next world.
I'm very excited for what you're saying. As a Counter-Strike player, wall hacks and these kind of things are big issues, but I don't know how you can solve cheating with zk. That would be an interesting area, but like you, I fail to see how that could help.
You mentioned application. How, like, tangibly, what's the next step to get people actually working on application? It feels like we always just kind of throw it at hackers at hackathons and go like, here, go for it.
Yeah, so from what I've seen in the non-blockchain world, like people will think about applications first, and then they will try and figure out what are the cryptographic primitives or the frameworks or libraries that you can use to solve their problems. And they never think about, oh, I have zk at my disposal, how can I use it? It's always in the other way, it's always backward. And so I think the only thing we can do in zk is just make better frameworks or make it more usable and faster for client-side proving and all these things, better certain frameworks or zk, whatever, like really reduce the friction to use this and also improve the security guarantees. Like it's pretty novel. We don't know how secure it is. I'm sure there's going to be a lot of bugs in the next years as we sort of ossify. We have a period of ossification. And so that's all we can do. And on the other side, there will be people trying to build. They will sort of discover zk because they'll figure out, oh, I can actually use zk to solve these issues I'm trying to solve within my protocol. So usually zk is just one part of it. And so if we're there, like extending our hands, then we'll catch our hands and use whatever we have.
That's an interesting take. I hadn't really thought of it that way. But people do seem to know what zk is nowadays, at least some people that I talk to. And like, we should kind of just be ready for them to need it for a problem instead of going out and trying to find the problem.
Otherwise we're like a solution in search of a problem. Right?
Do you feel like we had like a good, clear presentation and cohesion around what it is we offer?
I think it's probably hard for most people to understand what zk really does, and yeah, it'll get better. I mean, as most people who want to use zk are usually more low-level people. It's the same way if you're gonna use like a TE or a Nitro or an HSM or all these things. Like you're probably a low-level developer and you sort of know what you're looking for. You're searching in that space already, and so if that's our audience, then maybe it's not that big of a deal. Maybe we've already done a good job. Yeah, good question.
Does anyone from the audience have any questions for these folks? Cool. Yeah, you at the back?
Yeah, so is it safe to assume that Plum-E3 won't be prioritizing adding privacy anytime soon?
That's it. That's not safe to say. If someone wants it, we can look at it. Right now, I think it's not too bad, actually. Most of the stuff to do actual zk is not blocked by us. It's blocked at the application layer, the user of Plunky3. I guess it would mostly be Merkle blinding, which I think we can do pretty easily. And anything else they need to do, like lookup blinding or something, is I think on top of Plunky3. So I think Merkle blinding might be the only blocker. But don't quote me on that.
Anyone else? Cool.